It's October 27th, 1943. Inside a dimly lit laboratory at the Tokyo Imperial University, Professor Hiroshi Nakamura hunched over his workbench, carefully examining an American cartridge case under a powerful microscope. Outside, autumn rain tapped against the windows, providing a rhythmic backdrop to his meticulous work. The distinguished metallurgist was certain that Japanese manufacturing standards were superior to American mass production methods, a belief that would soon be shattered by what the microscope revealed. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the untold story of how a group of Japanese scientists discovered a humbling truth about industrial capability during World War II, and how that revelation would fundamentally transform their understanding of why their nation's weapons were failing at critical moments when their soldiers needed them most. In the early years of the Pacific conflict, Japan had experienced remarkable successes. The Imperial Japanese military had advanced rapidly across vast territories, showcasing the effectiveness of their strategy and equipment. Their initial victories had reinforced a sense of technological superiority among Japanese military leadership and scientific advisors. American manufacturing is rushed and careless, Professor Nakamura had written in his preliminary report to the Imperial Japanese Army Ordnance Bureau. Their mass production methods sacrifice quality for quantity. This should give our precision-crafted weapons a significant advantage in extended conflicts. Lieutenant General Takeo Yasuda, head of the Army Ordnance Bureau, nodded approvingly as he reviewed Nakamura's report in his Tokyo office. The polished wooden desk before him was arranged with perfect precision, reports aligned at exact right angles, pencils arranged by length. The 54-year-old officer had risen through the ranks based on his attention to detail and unwavering dedication to Japanese military traditions. These American cartridge cases we've recovered from the Pacific Theater will confirm what we already know, Yasuda told his aide, Captain Kenji Tanaka. Their hasty production methods will be evident in metallurgical imperfections. Document everything for our manufacturing improvement program. Captain Tanaka, the 32-year-old engineering graduate who had been selected for his role due to his exceptional academic record, bowed slightly. Yes, sir. Professor Nakamura's team is already examining the samples. We expect preliminary results within 2 weeks. What neither man anticipated was how these findings would challenge everything they believed about their industrial capabilities. 300 miles away, in a forward operating base on Rabaul, Sergeant Ichiro Sato crouched in a defensive position, frantically attempting to clear his jammed Type 99 rifle. Around him, members of his unit faced similar struggles as their weapons malfunctioned during a critical defensive operation. Sweat dripped down his face, partially from the oppressive tropical heat and partially from rising panic. "Again?" hissed Private Matsuda next to him, his own rifle malfunctioning for the 3rd time that morning. "How are we supposed to defend our position when our weapons won't fire?" Sergeant Sato had no answer. As a veteran who had served since the beginning of the conflict, he had noticed a troubling pattern emerging. The reliability of their weapons seemed to be deteriorating as the war progressed. What had started as occasional malfunctions had become alarmingly frequent. "Clear it as best you can and conserve ammunition," Sato ordered, successfully unjamming his own rifle after several tense moments. "Single shots only, make each one count." He didn't voice his deeper concern, that something fundamental was wrong with their equipment, something beyond simple maintenance issues. Back in Tokyo, Professor Nakamura's investigation was taking an unexpected turn. The 56-year-old scientist had expected to find evidence of American manufacturing flaws. Instead, his microscopic examination was revealing something that contradicted his initial hypothesis. "This can't be right," he muttered, adjusting the microscope for the 3rd time. "Tanaka-san, please verify these measurements." Shigeru Tanaka, his 45-year-old research assistant and metallurgical specialist, moved to the adjacent microscope to examine a different American cartridge case. After several minutes of careful observation, he looked up with a troubled expression. "The consistency is remarkable, Professor. The brass alloy composition appears uniform throughout all samples, and the casings maintain precise dimensional tolerances. I've checked 37 casings so far, and the variation is less than 0.003 millimeters. Professor Nakamura frowned, removing his glasses and rubbing his tired eyes. That level of consistency should be impossible with mass production techniques. Are we certain these are American manufactured? Absolutely, sir. These were recovered from American positions on Guadalcanal. The head stamps clearly indicate production at various American facilities during 1942. Then we must expand our analysis. Prepare comparative samples of our own cartridge cases from different manufacturing periods and facilities. I want a comprehensive metallurgical comparison. As Nakamura's team began their expanded investigation, Lieutenant Colonel William Peterson sat in a military manufacturing consultation office in Detroit, reviewing production reports from ammunition plants across America. The 48-year-old officer had been an industrial engineer before the war and now served as a liaison between military requirements and civilian manufacturing. "These numbers are impressive, Miss Thornton," he told his administrative assistant, reviewing the latest weekly production figures. "Winchester alone produced 16 million cartridge cases last week, and their quality control rejection rate remains under 1%. Emily Thornton, a 36-year-old former schoolteacher who had joined the war effort after her husband deployed overseas, nodded as she organized the next set of reports. "Remington and Federal are showing similar results, sir. The standardization program you implemented last year seems to be paying dividends." Peterson nodded, allowing himself a moment of satisfaction. "It's the industrial capacity that will win this conflict. Every production line, every factory worker, every quality control innovation, that's our true advantage." What Peterson couldn't know was that the very ammunition he was helping to produce in such vast quantities would soon provide Japanese scientists with a humbling revelation about industrial capability. 2 weeks after beginning their comparative analysis, Professor Nakamura called an emergency meeting with the Army Ordnance Bureau. The findings were too significant to be communicated through standard reports. Lieutenant General Yasuda arrived at the Tokyo Imperial University Laboratory with Captain Tanaka and Major Hideki Saito, the Bureau's chief production coordinator. The 3 officers were escorted to a conference room where Professor Nakamura and his research team had arranged a comprehensive display of their findings. "Thank you for coming on short notice, General," Nakamura began, bowing respectfully. "What we have discovered requires immediate attention and may necessitate significant changes to our manufacturing processes." General Yasuda nodded curtly. "Proceed with your findings, Professor." Nakamura gestured to a large comparison chart on the wall. "We began by examining American cartridge cases to identify potential weaknesses we could exploit. Instead, we found evidence of manufacturing consistency that exceeds our own capabilities." He directed their attention to metallurgical cross-sections displayed through projection microscopes. American cartridge brass shows remarkably consistent grain structure and alloy distribution. The copper-to-zinc ratio maintains precise 70-30 proportions throughout the case, with minimal impurities. Captain Tanaka leaned forward, his engineering background allowing him to immediately grasp the significance. "The annealing is perfectly executed as well. No stress fractures at the neck or base." "Precisely," Nakamura confirmed. "Now, in comparison, here are samples from our own ammunition production facilities." The contrasting images were troubling. Japanese cartridge cases showed visible inconsistencies in metal grain structure, varying alloy composition, and evidence of improper annealing. "The quality variation between our different manufacturing facilities is substantial," Nakamura continued. "Cases produced early in the conflict show reasonable quality, but more recent production exhibits increasing inconsistencies. More concerning is the variation between individual cases from the same production batches." Major Saito frowned. "Are you suggesting American mass production is achieving higher quality than our methods?" "The evidence is incontrovertible," Nakamura replied. "Their standardized production systems, rather than sacrificing quality for quantity as we assumed, are actually achieving both simultaneously. More importantly, they're maintaining this quality while increasing production volume." General Yasuda's expression remained impassive, but his fingers tightened around the pen he held. What are the practical implications? The inconsistency in our brass cartridge cases directly correlates with the increasing weapon malfunctions reported from the field, Nakamura explained. Dimensional variations cause feeding issues. Improper annealing leads to case ruptures. Inconsistent primer pocket depths result in misfires. He placed a field report on the table. According to data from the South Pacific, our troops are experiencing malfunction rates exceeding 20% in some engagements. American forces report rates below 2%. The room fell silent as the implications became clear. It wasn't just an ammunition problem, it was a fundamental industrial capability gap. At the same moment, thousands of miles away in a manufacturing facility in Bridgeport, Connecticut, production supervisor Martha Collins was conducting her daily quality control inspection. The 41-year-old former office manager now oversaw a production line staffed primarily by women, many of whom had never worked in manufacturing before the war. "How are we looking on tolerances today, Ruth?" she asked, approaching a quality control station where 27-year-old Ruth Daniels was measuring cartridge case dimensions. Ruth, who had been a department store clerk before the war, looked up from her micrometer. "Holding steady within .002 inches, Mrs. Collins. We've processed 12,000 cases since this morning, with only 78 rejects." Martha nodded approvingly. "Excellent. And brass composition?" "Chemistry lab reports all batches within specification. The new annealing process adjustment has reduced neck splits by nearly 80%. What neither woman realized was that their attention to precision and quality, multiplied across hundreds of American factories, was creating an insurmountable advantage that Japanese manufacturing couldn't match. Back in Tokyo, the implications of Nakamura's findings were beginning to ripple through the military leadership. A follow-up meeting was convened at Imperial Army headquarters, bringing together representatives from multiple branches to address the manufacturing crisis. General Yasuda presented the findings with clinical detachment, though the information clearly pained him. Professor Nakamura's analysis confirms that our ammunition quality has been declining while American production maintains superior consistency. This directly impacts weapon reliability in combat operations. Colonel Hiroshi Yamamoto, representing the infantry division, leaned forward with visible frustration. "My men report increasing incidents of jammed weapons during critical engagements. If this is due to ammunition quality, rather than weapon design or maintenance, we must address it immediately." "The problem extends beyond ammunition," interjected Naval Captain Toshiro Ikeda. "We're seeing similar quality inconsistencies in naval artillery shells. Dud rates have increased significantly since 1942. Major General Masao Ito, Deputy Chief of the Army General Staff, studied the metallurgical reports with a deepening frown. "What are our options for improvement? Can we implement American methods?" "That's the true challenge," General Yasuda replied. "Professor Nakamura's team has identified that American quality comes from a combination of factors we cannot quickly replicate: standardized production equipment across multiple facilities, statistical quality control methods, precision measurement systems, and most importantly, an industrial base capable of producing machine tools with exceptional accuracy." He placed another document on the table. According to intelligence reports, a single American factory, Ford's River Rouge plant, can produce more engine blocks in one day than all of our facilities combined produce in a month, while maintaining tighter tolerances than our best craftsmen achieve. The silence in the room was heavy with realization. It wasn't simply a matter of copying American techniques. Japan lacked the fundamental industrial infrastructure to match American production quality and quantity. Colonel Yamamoto finally spoke the uncomfortable truth. "This is not merely a technical problem. It is a strategic vulnerability that could determine the outcome of the conflict." In the following weeks, Professor Nakamura's team expanded their investigation to examine broader manufacturing capabilities. The findings were increasingly troubling. American industrial advantages extended far beyond ammunition, affecting virtually every category of military equipment. In his laboratory, Nakamura examined a disassembled American M1 Garand rifle alongside a Japanese Type 99. The differences in manufacturing quality were immediately apparent to his trained eye. "Notice the machining consistency on the American bolt assembly," he explained to Shigeru Tanaka. "Each component maintains precise tolerances, allowing for interchangeability between rifles. Our components require hand-fitting by skilled gunsmiths, limiting both our production rate and field repairability." Tanaka nodded. "Their mass production techniques achieve what our craftsman approach cannot, both consistency and volume." Nakamura sighed heavily. "It is a fundamental philosophical difference. We value the skilled craftsman and expect variation between individual items. They design systems that eliminate human variation while maintaining quality." "Can we adapt our approaches?" Tanaka asked. "Not quickly enough to affect the current situation," Nakamura admitted. "We would need to redesign our entire industrial base, something that would take years even in peacetime." Meanwhile, at the Yokosuka Naval Arsenal, Commander Jiro Takahashi was conducting his own investigation into torpedo reliability issues. The 47-year-old naval engineer had been tasked with determining why Japanese torpedoes were increasingly failing to detonate against American ships. His findings paralleled Nakamura's. Metallurgical examination of torpedo detonator components revealed inconsistent material quality and precision, directly impacting reliability. American torpedoes, despite early problems that had been systematically addressed through engineering improvements, were now achieving higher success rates through standardized manufacturing processes. The most concerning discovery came when Commander Takahashi analyzed the quality trend over time. Japanese components produced early in the conflict showed higher quality than more recent production, exactly the opposite of the American pattern, where quality improved as production increased. "Our industrial capacity is being stretched beyond its capabilities," he wrote in his report to Naval Headquarters. "As we attempt to increase production with limited resources, quality inevitably suffers. The Americans, conversely, improve quality while expanding production. The implications extended beyond immediate battlefield effects. This was evidence of a fundamental strategic miscalculation. Japan had initiated a conflict against an industrial giant whose production capacity it could never match." By December 1943, the accumulated evidence from multiple technical investigations had reached the highest levels of Japanese military leadership. An emergency conference was convened to address the industrial capability gap and its strategic implications. Field Marshal Hajime Sugiyama, chief of the Imperial Japanese Army General Staff, listened gravely as General Yasuda presented a comprehensive analysis of the manufacturing quality crisis. Based on Professor Nakamura's findings and corroborating evidence from multiple service branches, we face a fundamental disadvantage in industrial capability, Yasuda explained. American war material is produced in vastly greater quantities, while maintaining quality standards we cannot match with our current manufacturing infrastructure. Admiral Mineichi Koga, Commander-in-Chief of the Combined Fleet, added his perspective. "Naval operations are increasingly hampered by equipment reliability issues. Torpedo failure rates exceed 30% in recent engagements. Aircraft engine reliability has declined significantly as production pressure increases." Field Marshal Sugiyama studied the reports before him. "What immediate measures can we implement to address the ammunition quality issues?" "We've already redirected our most skilled workers to ammunition production and implemented stricter quality control," General Yasuda replied. "However, we face fundamental resource limitations. Copper and zinc supplies for brass production are increasingly restricted by the American blockade. We've begun substituting steel cartridge cases, but this introduces new technical challenges." "The Americans face no such resource constraints," Admiral Koga noted. "Intelligence reports indicate their copper production increased by 40% last year alone. They can manufacture brass casings without limitation." The strategic implications were becoming unavoidably clear. Japan had entered a conflict against a nation whose industrial capacity it had fundamentally underestimated. At the Tokyo Imperial University, Professor Nakamura continued his analysis, now focusing on adapting Japanese manufacturing techniques to improve quality within existing constraints. Working with military engineers, he developed modified production processes that could be implemented without requiring entirely new industrial infrastructure. "We cannot match American production capacity," he explained to a group of manufacturing supervisors from various ammunition plants. "But we can implement statistical quality control methods and more rigorous material testing to improve consistency." The supervisors listened attentively, but their expressions revealed skepticism about implementing such changes while maintaining production quotas. One supervisor from the Tokyo arsenal raised his hand. "Professor, these methods require reducing production speed and increasing inspection personnel. How can we implement these changes while meeting military demands for increased output?" It was the central dilemma. Quality improvements would necessarily reduce quantity, at least initially. In a conflict where Japan was already outproduced by a massive margin, this presented an impossible choice between quality and quantity. On the front lines, the consequences of this industrial disparity were becoming increasingly apparent. At a forward base on Bougainville, Lieutenant Masaru Tanaka of the 3rd Infantry Regiment was conducting an impromptu inspection of his platoon's rifles before a patrol. "Strip them down completely," he instructed his men. "Check for any damaged components or excessive wear. Make sure all ammunition is from the newest shipment. Discard any cartridges that show discoloration or dimensional irregularities." Sergeant Sato, now serving under Lieutenant Tanaka after a transfer from Rabaul, demonstrated the inspection procedure to newer recruits. "Look carefully at the brass casings. If you see green corrosion or uneven coloration, set those rounds aside. Better to have fewer reliable rounds than more unreliable ones." Private Kenji Watanabe, a recent replacement who had arrived just 2 weeks earlier, examined his rifle with visible concern. "Sir, is it true American rifles don't jam like ours?" Lieutenant Tanaka considered his response carefully. "Their weapons face the same conditions we do. The difference is in their ammunition consistency and their ability to replace damaged rifles. We must compensate through diligence and skill." It was a diplomatic answer that avoided the uncomfortable truth. American troops could rely on their equipment in ways Japanese soldiers increasingly could not. In February 1944, Professor Nakamura presented his final comprehensive report on the ammunition manufacturing crisis to military leadership. The document detailed both the technical problems and recommended solutions, while acknowledging the fundamental industrial limitations Japan faced. "Our analysis confirms that declining ammunition quality is primarily due to 3 factors," he explained during his presentation. "First, increasing production pressure with limited industrial capacity. Second, decreasing raw material quality as primary sources become inaccessible. Third, loss of skilled workers to military service and other war production priorities." General Yasuda, who had become the primary military advocate for addressing the quality crisis, asked the question on everyone's mind: what can realistically be implemented given our current constraints? Nakamura outlined a prioritized approach. "We recommend concentrating our best materials and most skilled workers on producing ammunition for frontline combat units, accepting lower quality for training and secondary operations. Additionally, we've developed modified brass alloy formulations that use less copper while maintaining adequate performance." What went unspoken was that these measures would merely slow the declining quality trend, not reverse it. The fundamental industrial gap remained insurmountable within the time frame of the current conflict. In a parallel effort, Japanese military intelligence had been tasked with gathering more detailed information on American manufacturing methods. Lieutenant Colonel Takashi Watanabe of the Imperial Japanese Army Intelligence Division had assembled a comprehensive report based on pre-war industrial publications, technical journals, and limited intelligence from Japanese operatives in the United States. American manufacturing superiority derives from their system-based approach rather than reliance on individual craftsmanship, Watanabe explained to the Army General Staff. They design production processes where precision is built into the machinery itself, allowing less skilled workers to produce consistently high-quality components. He displayed a series of photographs showing American assembly lines. Note how specialized machine tools perform single operations with high precision. Workers require minimal training for specific tasks. Quality control uses statistical methods to identify process variations before they affect final product quality. Field Marshal Sugiyama studied the images thoughtfully. Could we implement similar methods? Not without fundamentally restructuring our industrial base, Watanabe replied. Their system relies on an abundance of precision machine tools, which themselves require sophisticated manufacturing capabilities to produce. It's a self-reinforcing advantage developed over decades of industrial evolution. This was perhaps the most sobering realization. Japan's industrial disadvantage wasn't simply a matter of current resources or priorities. It represented a fundamental developmental gap that couldn't be bridged during the time frame of the conflict. As 1944 progressed, the impact of industrial disparities became increasingly evident across all theaters of operation. Japanese forces found themselves not only outnumbered, but increasingly out-equipped by American forces whose weapons, vehicles, and equipment maintained consistent reliability under combat conditions. In April 1944, Major General Masao Ito visited the Tokyo Arsenal to observe the implementation of quality improvement measures recommended by Professor Nakamura's team. Walking through the production floor, he noted the increased inspection stations and modified production processes. "Has this affected our output?" he asked the facility director, Colonel Hiroshi Saito. "Production volume has decreased by approximately 15%, Saito acknowledged. However, rejection rates have decreased by nearly 40%, resulting in more usable ammunition reaching frontline units. General Ito nodded approvingly. Quality must take precedence over quantity at this stage. One reliable round is worth more than 5 that might malfunction. Yet even as Japanese manufacturing struggled to maintain quality, American production continued to expand in both volume and consistency. Intelligence reports indicated that new American ammunition plants were coming online, each with production capacity exceeding all of Japan's facilities combined. Lieutenant General Yasuda, reviewing these reports in his office, felt a profound sense of foreboding. "We're fighting not just American soldiers," he told his aide, Captain Tanaka, "but the entire American industrial system. Every factory worker, every engineer, every innovation in their manufacturing processes, these are our true opponents." In May 1944, Professor Nakamura presented a series of lectures to engineering students at Tokyo Imperial University, sharing the lessons learned from his ammunition analysis while being careful not to reveal sensitive military information. The future of Japanese industry must embrace systemic approaches to quality, he told the young engineers who would eventually be responsible for rebuilding Japan's industrial base. Individual craftsmanship remains valuable, but must be complemented by statistical quality control, standardization, and precision manufacturing systems. Among the students was 23-year-old Tatsuro Toyoda, whose family operated a textile loom company that had begun experimenting with automobile production before the war. The young man listened intently, taking detailed notes on American manufacturing methodologies. "Professor," he asked during a discussion period, "how can smaller companies implement these statistical quality approaches without the resources of major industrial powers?" "An excellent question," Nakamura replied. "The principles of quality control can be applied at any scale. Start with standardization of components and processes. Implement inspection systems that identify problems at their source rather than at final assembly. Most importantly, view quality as a systematic process rather than an individual responsibility." These concepts would eventually influence post-war Japanese industrial philosophy, though neither Nakamura nor Toyoda could have anticipated the global manufacturing revolution that would result. By summer 1944, the strategic situation had deteriorated significantly for Japanese forces across the Pacific. American industrial might was being brought to bear with overwhelming effect, not just in quantity of war material, but in its consistent quality and reliability. In a forward base on Saipan, Sergeant Ichiro Sato found himself in an increasingly desperate situation. His unit had been engaged in defensive operations for days, with dwindling supplies and mounting equipment failures. "Conserve ammunition and check each round before loading," he instructed his men, a procedure that had become standard practice as ammunition quality concerns spread throughout the ranks. "Single shots only. Make each one count." Private Matsuda, who had served alongside Sato since Rabaul, grimaced as he inspected his cartridges in the dim light of their position. "4 out of this clip look suspect. The brass is discolored and the primers are seated unevenly. Set those aside," Sato ordered. "Better to have fewer rounds you can trust." The need to inspect each round of ammunition before combat represented a significant tactical disadvantage, one more manifestation of the industrial quality gap that was increasingly determining the conflict's outcome. In Tokyo, the lessons from Professor Nakamura's ammunition analysis had expanded into a broader industrial quality improvement initiative. While limited in its immediate military impact, these efforts represented the beginning of a fundamental shift in Japanese manufacturing philosophy. Nakamura, now serving as a special advisor to the Ministry of Commerce and Industry, alongside his university duties, worked to document and codify the quality control methods that would be essential for post-war industrial reconstruction. "We must transform our understanding of industrial quality," he explained in a meeting with government and industrial leaders. "The American approach demonstrates that systematic quality control creates advantages in both productivity and reliability. These principles will be essential regardless of the conflict's outcome." In September 1944, Lieutenant General Yasuda visited Professor Nakamura's laboratory one final time. The military situation had deteriorated significantly, and both men understood that Japan's industrial limitations had played a crucial role in that decline. "Your work has been invaluable, Professor," Yasuda said, examining the comparative displays of American and Japanese manufacturing techniques. "Though the immediate military applications have been limited by our industrial constraints, the long-term implications for our nation's future are significant." Nakamura nodded solemnly. "The most important lesson is that quality cannot be inspected into a product. It must be built in from the beginning through systematic processes. This understanding will be crucial for rebuilding our industrial capacity." Neither man directly acknowledged the increasingly apparent outcome of the conflict, but both understood that Japan's future would require embracing the industrial quality lessons revealed through their wartime analysis. In the post-war years, the insights gained from Professor Nakamura's ammunition analysis would contribute to Japan's industrial transformation. The recognition that American manufacturing achieved both quantity and quality through systematic approaches rather than individual craftsmanship became a foundational principle for rebuilding Japanese industry. Engineers like young Tatsuro Toyoda, who had attended Nakamura's lectures, would eventually pioneer manufacturing systems that built upon American quality control methods while adapting them to Japanese industrial culture. The Toyota production system, with its focus on built-in quality and continuous improvement, would represent the culmination of lessons that began with studying American bullet casings during the conflict. By the 1960s, these approaches had evolved into comprehensive quality management systems that would eventually make Made in Japan a global symbol of manufacturing excellence, a remarkable transformation from the quality challenges identified during Professor Nakamura's wartime investigations. The journey that began with Japanese metallurgists examining American bullet casings ultimately led to a revolution in global manufacturing philosophy. What started as a humbling discovery about industrial capability gaps became the foundation for one of history's most significant industrial transformations. In his later years, Professor Nakamura would sometimes reflect on the irony that Japan's greatest industrial advancement came from studying the manufacturing techniques of its former adversary. The lessons learned from failure and adversity had ultimately led to unprecedented success. The true measure of a nation's resilience, he wrote in his memoirs, is not found in victory, but in how it learns from defeat. Our examination of American bullet casings revealed not just why our weapons jammed, but how our entire industrial philosophy needed to evolve. This story of metallurgical discovery represents more than just a technical footnote in military history. It illustrates how fundamental industrial capabilities often determine strategic outcomes more decisively than battlefield tactics, and how the lessons learned from such discoveries can transform nations in unexpected ways. The Japanese scientists who began by searching for American manufacturing weaknesses instead found a profound truth about industrial quality that would eventually help rebuild their nation into an economic powerhouse. Their humbling discovery about bullet casings would eventually lead to revolutionary approaches to manufacturing that would influence industries worldwide. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II, and check out the video on screen for another incredible tale from history. Until next time.